A very good evening to all the students who have joined in here and to the faculties too. We will be starting the session sharp at 5 p.m. So kindly inform your friends to join in quick. Good evening to all the students. We will be starting the session in few minutes around 5 p.m. So kindly tell your friends to join in quickly for the session. Thank you. A very good evening to all the students and directors, professors, and other faculty members who have joined in here today. On behalf of XLR, I sincerely thank you all for taking your time to be a part of the student development program on quantum computing. So before we begin, let me give you a quick introduction to XLR. XLR was founded by an IIM ISB alumni in the year 2013, and it has 8 branches in 8 cities with its headquarters in Houston, USA. So far, XLR has trained over 8 lakh plus students and professionals across various domains, catering to individuals, institutions, and industry. So few of our premium associations include iHub Divya Sampark, Naipunyam Skill Task Telangana, Swam Plus, and many more. With over a decade of excellence in training, we have conducted 1,000 plus webinars, offered 30 plus technical courses, collaborated with 2,000 plus academic partners, and worked with 5,000 plus placement partners. We also have trained around 80,000 plus faculties through the faculty development program and 8 lakh plus students through the student development program. So far, in Excella, we have about 8,28,853 students participating and 76,577 faculties participating in our everyday learning program. For today's student development program on quantum computing, we have about 3,548 registrations with 1,002 registrations from Maharashtra, followed by 989 from Telangana and many more. We also have registrations from different streams such as engineering, MBA, degree, and MCA. Our everyday learning program, it focuses on providing application and industry-oriented learning on trending technologies for free from industry experts with in-depth knowledge on the subject. The goal is to provide hands-on learning experience, provide and help students and faculty with real-world application, and support institutions in meeting their NAAC and NBA requirements. You can find the registration link in the chat box too. A learner can click on it to register, or they may also visit the XLR website to complete their registration. And upon successful completion of the program, participants will receive a participation certificate. Additionally, we also collaborate with colleges by signing MOUs to conduct and collaborate for the student and the faculty development programs, along with placement readiness drives to support students in their career development. Through the EDL program, a learner or a participant benefits from the following. We have 30 plus hours of professional training, assignments and assessments, real-world use cases, placement preparation sessions, coding challenges and campus recruitment training, a lifetime LMS access, and certificates for participation. So this is how our LMS dashboard looks like. Students can log in using their username and password that they have received through their email after registration. And then they can access the courses they have enrolled in. They can also view the courses they have registered for in the past. So far, we have conducted almost 785 plus student development programs with a total of 2,300 hours delivered. And we have regularly 2,000 plus colleges participating and around 8 lakh plus students every time they're registering. Among the students, we have Salesforce, ChatGPT, Python programming, and full stack development program, which are more common. This is regarding the faculty development program, where we have conducted 60 plus with a total of 600 hours delivered, and a total of 2 lakh plus faculties have enrolled, and with again 2,000 plus colleges who participate regularly for the faculty development program. And among the faculties, we have deep learning, digital marketing, data analytics, and ChatGPT, which are more common. So this is how our faculty and the student development certificates look like. These certificates will be given to the learners after they register for the program and attend the live online classes regularly every single day. It is also important for the learners to mark their attendance in each session so as to be eligible to receive the certificate upon completion. So these were a few recent engagements with our premium institutions. We have successfully conducted programs at prestigious institutions like IIT Roorkee, where we have conducted training on data analytics using Minitab for the faculty and the research scholars. This was a student initiative from BITS Pilani Hyderabad campus, where students had approached XLR to conduct programs on Power BI and machine learning. We also had a skill up program for the final years, which was a 240 plus hours of campus recruitment training with placement assistance that had started from Jan 2024 up to April 2024, and it had covered coding skills, quantitative aptitude, logical reasoning, verbal ability, soft skills, and at the end there was resume and LinkedIn profile building. Apart from that, there was also a group discussion and personal interviews for the students. This is the participation certificate that was provided to the students after completion of the Skill Up program. And this was issued by IHUB Divya Sampal, which is a joint initiative of IIT Roorkee and Government of India's Department of Science and Technology, where you can see here, only 5,000 students out of 50,000 students were eligible for the certificate that was given based on their attendance and their assignments. These are a few newspaper snippets covering the Skill Up program, where we had maximum registrations from APSSGC, where we had 10,150 engineering students who had attended this online Skill Up program. Among the ADL, in May, we had conducted the following program. This was in June and the following month in July. So coming to today's student development program on quantum computing, it is my pleasure to introduce our esteemed guest for today. We are honored to have distinguished academicians with us who bring us decades of experience, research excellence, and contributions to education and innovation. Firstly, we have Dr. Balaji, who is a professor and director of the MCA department from Surana College, Autonomous, Bangalore. His academic and accreditation leader, spearheading the MCA department to become the first among the arts, science, and management colleges in Karnataka to receive MBA accreditation. His experienced academic contributor, serving as BOS and BOE member, research thesis evaluator, conference session chair, and reviewer for reputed institutions and national and international conferences. His research and professional contributor with a patent submission, extensive NAC coordination experience, and professional memberships in CSI and IFERB. So, welcome to our session, Dr. Balaji, sir. We would like to hear a few words from your end.
Thank you so much, ma'am. Can you hear me?
Yes, sir, you're audible.
That's fantastic. Second. 1 minute. I'm sharing the screen.
Okay.
Very happy evening to everyone. Nice to see you all. Thanks to XLR. It's indeed my great pleasure and privilege to me to inaugurate the student development program on quantum computing. XLR, we are personally from Surana College, Autonomous, Bangalore. We are 30 plus years college, and we got NAC A plus grade and accredited by AICTE. From 21 we become autonomous. And proud moment that Department of MCA we got accreditation in the just recently in the January 2026. And we are very proud and happy to be associated with XLR for especially for our MCA program. Because as a MCA program, which is a premier college in Bangalore with a 30 plus year experience, we want to have a more collaboration with the industry and as well as corporate partner. And I'm very sure that XLR is doing the great job. So as a Sorana college and as a department of MCA, NBA accredited colleges, we are very happy to associate with XLR. First of all, I would like to congratulate the organizers, that is XLR, the wonderful committee members, and everyone involved in this bringing this program to all the students fraternity. And choosing the quantum computing is the theme for the student development program is both timely and also it's a timely program and also forward looking. And we are living in the period of where technology is changing in the different extraordinary pace. And everybody are talking about artificial intelligence, machine learning, cloud computing, cyber security, and data science have already transformed the way we are living with. Now we are entering into the another era called again what we are going to call as a quantum computing. And we are many of us familiar with the classical computers. This we know the process of information using bits and there is zeros, ones, binary, everything. But as a quantum computers, we are going to use quantum bits, qubits, which take the advantage of the principles of quantum mechanics, such as superposition and extraction. And these principles we are going to provide you fundamentally different approach to the computation world. And I also emphasize all the students community, those are going to participate in this particular SDP. You should not have only to talk whether I'm going to learn what about things I only studied quantum physics or not. I'm going to learn what about the quantum computing. It can be the computing can be students can learn from anybody of computer science or MCA or engineers or those who studied maths, physics, data science, etc. Only thing is, it will be increased for your mathematical thinking, programming skills, and willingness to learn. That is only more important for you. So, all my dear students, programmers that's like this should not be viewed as only I want to take a certificate, I want to utilize it. Don't use that one. Maximum try to ask as many number of questions. You can do experiment and write small programs, understand quantum algorithms, and connect whatever you want to learn for the tomorrow's world. And also, I therefore encourage every one of you to approach this program with an open mind. Don't advance yourself. Even the advanced technology begins with a few basic concepts because everybody cannot know everything. So, it's just a beginning of your first step you are going to do. So, I sincerely hope this program will inspire you to explore further, undertake projects, participate in the research, or even the innovative solution in the quantum technologies. So once again, I congratulate the XLR and thank you so much for aligning or having the tie-up with our Sorana College, Autonomous, Bangalore, one of the premier institutions in India, and with the Department of MCA, the very few people got NBA accredited. Ours is one of our department. So in these words, I am very happy for participating this program, and thank you. I wish all the participants a wonderful and excellent experience journey. Thank you once again. Yeah, once again.
Thank you so much, sir, for such an informative and insightful talk. It's a pleasure to have you for today's session, sir. Thank you so much.
Thank you so much. All the best for everyone.
So next we have Dr. Vishali Wagmare, who is an assistant professor from MIT Academy of Engineering, Pune. Ma'am is accomplished academician and researcher in electronics and telecommunication engineering and currently serving as an assistant professor with a PhD in electronics and telecommunication engineering. She is an active academic contributor involved in curriculum development, technical workshops, professional development program, and expert lectures. Her dedicated to innovation and practical learning with experience in interdisciplinary projects and fostering a dynamic application-oriented learning environment. Vishali ma'am, we would like to hear a few words from you.
Thank you, ma'am. Am I audible to you?
Yes, ma'am, you're audible.
Good evening, all. It is my pleasure to present here in the student development program on quantum computing. As we know that we are living in an area of rapid technological transformation where we every day we are going to see a new technology. Okay, every day we are seeing that the various emerging technologies are coming, and that is shaping our engineering and also a society. So quantum computing is one such revolutionary technology that has the potential to transform the way we solve the complex problems. So quantum computing is expecting to play a very important role in several areas, or several emerging areas like artificial intelligence, cybersecurity, healthcare, drug discovery, finance, optimization, science research. Okay, so this is a very essential for the students to understand this emerging technologies and prepare themselves for the future. So program like this student development program providing an excellent opportunity to the students to go beyond the regular curriculum and explore the new and advanced areas of technology. Learning about quantum computing today will help the students to develop the knowledge, curiosity, skill and needed for the whatever the technology we require to face this rapid changes in day to day life. Okay. I would like to express my sincere appreciation and gratitude to the XLR for collaborating and providing such a valuable platform for the students to learn about emerging technologies. This collaboration is an excellent initiative that helps to bridge gap between the academic learning and the industry oriented skill. I encourage all the students to participate in this program to make most of the opportunity, learn actively, ask the question, explore new ideas, and develop a strong foundation for this exciting field. I'm confident that program will inspire the students to explore quantum computing, motivate them towards the innovation, research, and future technologies. Once again, I will sincerely thank the XLR for the valuable collaboration and for creating opportunity for the students to learn and grow in emerging area of the technology. Thank you, ma'am. I wish all the students for this student development program all the best.
Thank you so much, ma'am, for your kind words. Next, we have Dr. Manoj Vasant Balerao, who is the Vice Principal and HOD of Electronics and Telecommunication from Pune Vidyarthi Grihas College of Engineering and SS Damankar Institute of Management, Nashik. He is an academic and research in electronics engineering and holds a PhD from Satyabama University, Chennai, with 20 plus years of academic and technical expertise. His research specialist in wireless communication focuses on visible light communication, high data rate transmission, EMI reduction, and bandwidth optimization. He's focused on next generation communication systems, exploring VLC applications across domestic and industrial and vehicular environments for improved reliability and energy efficiency. So due to some problem, we couldn't have Dr. Manoj. So on behalf of him, we have Dr. Vijay Sanavne, who is the HOD of Computer Science Department. So Vijay sir, I will now request you to share a few words to the gathering.
Thank you, madam. So, good evening, one and all. Respected dignitaries from XLR, faculties from various other engineering, reputed engineering colleges, faculties from PVG engineering, and all dear students. More than 481 participants are there in this meeting. So, it's my great pleasure today to welcome you all on this student development program on quantum computing, which is organized here with in collaboration with XLR. Here, I would like to give brief information about our PVG. PVG stands for Pune Vidyarthi Griha. It is established in around 117 years ago. PVG is having various educational branches located in Pune, Mumbai, Nasik. We have engineering college in Pune also, Nasik Engineering College. It is established in 2010. We are having 5 UG branches along with one PG branch as a MBA. We are accredited with NAC A grade, and from this year onwards, we have received an autonomous status for next 10 years. So, dear students, we heard to the eminent speakers before me. So, the conclusion is that the rate of change of the technology is very high. We learn AI, IoT, cyber security, robotics, and now we are listening or learning about the quantum computing. These are all the technologies, they are creating the new opportunities and redefining the skills expected from a graduate engineer. Most of the time we listen that these technologies are going to take our jobs. AI, it will take our jobs. But there is a famous quote by Elon Musk. He said that AI will not take your job, but the person who will use the AI. Some months ago, we received letter from DT, Director of Technical Education, Maharashtra State, that they appealed to the engineering colleges to make the students compulsory to enroll for courses from NPTEL based on quantum computing. Why? Because in near future there will be the good jobs will be present available in the domain of quantum computing. Recently, the Chief Minister of Maharashtra State, he also appealed that in upcoming 100 days, there will be the good amount of jobs will be available on these cutting edge technologies. So, dear students, I really thanks to the XLR, as name implies Excel. They are really, I just gone through the presentation. They are really doing the excellent work, very good FDPs, student training, faculty training, they have been conducted till date. So this SDP, it plays a very good role. It provides the student an opportunity to learn beyond the curriculum, get the practical exposure, understand the emerging technologies, interact with the industry experts. So I encourage all the participants to use this program not to get the certificate only, but it is opportunity to you to explore, experiment, ask the question, and learn the new technology. I am sincerely thankful to the XLR for the collaboration and supporting the students in this emerging domain. Let's work together to transform from technology learner into the technology innovators. I wish this initiative a great success and hope it becomes the beginning of many more meaningful academic industry collaborations. So thank you, madam, for giving me an opportunity. Thank you. Thank you, one and all.
Thank you so much, sir, for an informating and insightful talk. It was a pleasure having you two with us today, sir. So next we have Dr. Ravi Gujula, who is a Chief Industry Connect and Skill Development from ICFI Hyderabad. He is a distinguished PhD graduate from IIT Hyderabad in Computational Fluid Dynamics. He blends over 15 plus years of corporate experience with a decade of academic and administrative excellence. The former chairman of the Board of Studies at KL University and a principal in Andhra Pradesh. He also excels in skill development, establishing centers of excellence and strengthening industry academia collaboration to make graduates industry ready. Dr. Ravi sir, we would like to hear a few words from your end.
Yeah, thank you very much, Seetal and team. Am I audible?
Yes, sir, you're audible.
Yeah. Yeah, good evening, everyone. Very warm welcome to all students who are registered for this today program, Quantum Computing for Student Development Program. So XLR I think they are launching the correct time, and this is a need of our to learn about the basics about the quantum computing in this 15 days faculty student development program. So basically, the first question is why are we talking about the quantum computing nowadays? So let me begin with a simple question. So how many of you heard about the term quantum computing before? Please raise your hands. Yes, very nice. Yeah, so the probably many of you know about, but the more important question is how many of you really understand what quantum computing can do? And even more important question is why should a student today learn quantum computing? So my answer is very simple because the technologies that will create tomorrow's job are being learned today. So we have seen this transformation much before 2 decades ago. A very few students 20 years back talking about cloud computing, artificial intelligence, data science, machine learning, and cyber security, even blockchain too, 20 years back. But today, these have been mainstream area of technology and employment. So probably when we are students, we know only BTech computer science. But just now what I mentioned, cloud computing, artificial intelligence, data science, machine learning, cyber security, blockchain, all these technologies, specialized BTech courses, BTech blockchain, BTech data science, right? So you have seen, I think probably you guys are in the part of these BTech programs. So the quantum computing is at a similar early stage, but today transformative consequences going to happen in the future. So our objective should not be wait to until quantum computing becomes a mainstream to start learning. So we should start learning it before it because it is going to be mainstream very very soon, which already started. So this is exactly why these programs like these are important for the students from first year to final year. So that's what exactly ICFI group universities we are initiating these kind of courses in collaboration with a XLR team to introduce these kind of programs for students that too in the 7 to 9 to focus to learn new things. This is the right time students are ideal and to know focus more on this. Then coming to again, what is this quantum computing represents? Why everyone is talking about the fundamentals? The Andhra Pradesh government they started a quantum valley first kind in India. So the importance of this program is, as you know, for simple problems, just building a website or to do some kind of simulations, these classical computers are extremely very good. But for certain complex problems, however, the quantum approaches may eventually provide enormous advantage. Just for example, the potential areas includes the complex problems like drug discovery, to how this drug whatever we are taking simply taking into the body, but this is going to act only in particular locations, but this drug is going to be intruded into all parts of body. So that drug discovery, healthcare system, financial modeling, cryptographies, cyber security, logistics and supply chain, these kind of domains, this quantum computing play an important role. So therefore, the quantum computing is not limited only to the computer science also, but I'm once again reminding quantum computer is not only to the computer science, even it is a interdisciplinary. Students of computer science, mathematics, physics, electronics, and finance guys also should know about this quantum computing. So can all potential find these connections with this emerging field? So that's what I would like to say. The most important message for the students. I want to remember one sentence from today's session. Don't prepare only for today's jobs. You don't know this today's job is going to be obsolete for next 2 years, or maybe in 4 or 5 years. But prepare for the technologies that will create tomorrow's jobs, because when you guys are in second year, when you reach final year, the present existing jobs are going to be obsolete. So that's what I'm just passing this message in this my talk. So the employment landscape is also rapidly changing. The industry is increasingly looking for the people who are interdisciplinary combined domain experience, like domain knowledge, technology, problem solving, and continuous learning. And guys, the quantum computing is no longer a topic confined to only research papers, but it is quietly becoming one of the most important technological shift of our generation, reshaping how we approach cryptography, drug discovery. And when you look at the countries and companies across the world are investing billions and billions of rupees into this space in the research domain, demand for the people who even understand the basic quantum of quantum computing principles is only going to grow. So students who began exploring this field today will be the one of who are prepared for tomorrow jobs. So that's what exactly every university, all universities looking for more industry connect to deliver what industries are expecting at the classroom. That's where I encourage XLR voluntarily organizing these free of cost programs to create awareness and to impart the basic fundamental quantum computing skills in everyday learning program in every 15 days in the evenings. So these kind of initiatives will, definitely will build a confidence in students, and also for their future career is going to be a bright, and students are going to be confident and future ready. So at this moment, I want to take a opportunity to uh, thanks and congratulations to the entire XLR team for offering this kind of courses at the need of our and to create the talent pool in entire pan India. So rightly mentioned the other co-panel speakers today, Dr. Balaji, Dr. Vishali, and Dr. Vinay. Everyone talking about the importance of this quantum computing. Really, I appreciate their message. And then the same thing, I want to leave you with this thought. This 15 days maybe sounds a little bit short time, but learning has never been about a number of days. It is about the doors you chosen to open. The quantum computing may be complex today, but every expert in this field once exactly where you are sitting now. It's a curious and little unsure, but all they did differently was decided to start. So I encourage every one of you who already registered for this program. Really, congratulations, and I encourage them to every student to ask questions, and sessions are more to be interactive, so that by the discussion, question and answers, where many of students uh, grasping the concepts and they are going to be explore to understand the thorough fundamentals. So thank you for giving XLR team for opportunity to share my thoughts, points uh, to the students to to express about this importance of this program. Wish you all the best. Thank you.
Thank you so much, Ravi sir, for an inspiring and insightful talk. And it has definitely left the students with some meaningful takeaways. Thank you so much, sir. So next we have our subject matter expert, Dr. Vipul Saxena, whose expertise with material scientist with 9+ years in quantum technology, advanced materials and client consulting, plus 8 years of experience teaching quantum computing and AI. He is a key contributor to graphene-based quantum devices, photonic qubit interfaces, and semiconductor materials for next-generation quantum hardware. His proven ability in project management, research, and global technical education across industry, academia, and professional platforms. Dr. Vipul sir, we would like to hear a few words from your side too.
Okay. Mm, So, good evening, everyone, and thanks to XLR that that they are organizing this entire organization team. So, it is very really nice to see the students. Great number of gathering here. Means the participants from different places coming together in a program like this. So I will not take much time because I think all of you are exhausted by listening everyone thoughts. But yeah, everyone was very interesting, and I was also listening to all that guest that what they are thinking about this quantum. So I understand that today is the beginning of the program, and all of you are eager to know what you are going to learn in the coming days now. Okay. So, but I would like to share just a few thoughts that we know when we look at higher education today, one thing is very clear that the technology scenario, or you can say the landscape, is changing very, very fast. So everybody is talking about that, right? And sometimes by the times a new technology becomes a part of the regular academic curriculum, the industry has already been started moving towards the next stage. Okay, so that doesn't mean our universities are not doing their jobs, and universities have a very important role. So they provide the foundation, means all of the basic sciences, mathematical science, engineering, fundamentals, it is everything they're providing, right? But at the same time, there is always a need for the students to look beyond the prescribed syllabus. So, and I think this is where the program like this, the student development programs, that becomes very, very useful. Okay. So that gives the students an opportunity to look at the areas where they may not normally studying in depth during their normal course of studying, that is a regular academic, you can say, program. So the students are hearing about today's everything. All the guests are talking about AI, quantum, robotics, data science, etc. Okay, and many more emerging areas we will look at in the next. So naturally, many students becomes very, very curious that what exactly is this technology, and Dr. Ravi has stated more about that. That where it is being used, and it is going to create the opportunities, but the students are also having some concerns. So what is this new technology, and what is this being used like that? Okay. So do I need to learn it? So students are very, very confusing at that point. So because in the market, when you see the corporate sector, so there are a lot of emerging technologies coming there. And at the student stage, you will be very, very confusing that what new technology we have to learn it or not. So this is very genuine questions, and personally, I feel that you could say at the student level, when I was a student, it is not necessary that everybody should immediately become an expert. So what I was thinking at that time, oh, I will learn this thing, I will learn this thing, and I will get a job like this. Okay, so this is not the point. The first step is to explore. Explore what? Explore, understand what is happening around you. Okay, so this is my very honest suggestion, that understand that what is happening around you, and understand the basic idea behind the technology, means behind every technology. Okay, so and then where it is actually useful and where it is not. At least you have to concentrate on these four questions before adopting a lot of technologies from the market. Okay, so, for example, when we are talking about quantum computing, yeah, of course, it's an emerging technology, it's still developing. There are many technical challenges we will talk about in the later lectures. Okay, so we should not tell the students that tomorrow all the classical computers will disappear by the application of this quantum computing. Okay, so everything will become quantum? No, 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 that would be wrong. Okay, so but should students understand the basic of the quantum computing? Yes, definitely yes, right? So with this thought, why? Because tomorrow this field may intersect with the areas such as means computing, materials, cybersecurity, and all that, optimizations and chemistry. So as Dr. Ravi and all previous speakers have said that when they were at the student, so like that when I was at the student, okay, so in my majority is in physics, okay, and when I was at the student, then I was compelled to study this quantum computation, means quantum mechanics, and the application of this quantum mechanics in the quantum computation. At that time, so this was the area about 20 years ago, 22 years ago. And at that time, the professors are already saying that, oh, forget about that. We are only formally teaching to you. Otherwise, it has no application. Okay, it is a very, very seldom use. But now that is coming at top time, right? So in my opinion, the programs like this should not be seen only as another certificate program. Okay. So yes, everybody was saying that. I will also emphasize on this fact that the real values comes when a student finishes the program and say, not finishes only is only the game. Okay. So say, now I understand this field. I know the basics and I know what questions to be asked. Okay. So if I want to go deeper, so I know where to start. So that's for me is meaningful learning. Okay. So before I conclude, I would like to say one thing to all the students. Okay, so that so this kind of collaboration is becoming increasingly very important. Okay, so what my suggestion will be. So I just want to end this thing that please don't come with into this program with the pressure that you have to understand everything in the first lecture itself or the first course itself. Okay, it is not possible. Okay, always every technology has to be adopted gradually. Okay, so this technology in this 15 days, okay, maybe possible, depends on the mind, depends on your absorbing speed, and also you are also having other subjects in your academic course also. Okay, so avoid the frustration if something you are getting or something you are not getting. Okay, so at any means by studying only a first time, you will get it everything. Yeah, I will commit from myself. Yeah, I will try my best. Okay, I will interact with you with the best level, but it may be possible, it may not be possible because you are all are having other subjects things also. You are running with your life. Okay, and this is your extra thing that you are doing, right? So don't play with your mind. Okay, that yes, I have done this, and I have not becoming this master. No, mastery not happens in a 15 days. Okay, but yeah, at least you should have answers all the things. Okay, that I will commit to you. Okay, so some topics may look difficult initially. That's completely normal. Completely normal. Okay, don't look at yourself. Don't look at teachers, and don't look at any other else. Okay, so just understand this is a very normal thing that something is being inserted in your mind, a very new things. So that will take your time. Okay, so give the time, have the patience, the new terminologies, new concepts, and the new tools. Okay, so understand the basics properly. Okay, if you are not getting expertise as you should aim your this thing that at least you are getting the basics properly. Why this technology is there in the market, what is the application of this. So if the aim should be, this is I am saying to avoid the frustration of yours. Okay, the aim should be when you are standing with the 10 or 15 peoples, or even you are standing with the some assistant professor or professors like that, okay, scholars, then you should not feel guilty that you are not having anything, okay, in the quantum computing. Okay, so you should so much that you have to learn it. Okay, so I hope that by the end of this program, I also will encourage all of you to actively participate and make the maximum use of this opportunity. But I will commit this also that you will, at the end of this, you will not only have learned something new, but you will also develop the curiosity to explore further. Okay. So with this, I'm just ending my thing. And once again, I would like to thank this XLR and the whole organizing team for inviting me. Okay. So I wish all the students and participants a very good learning experience. Thanks to all of you. And yes, Nitya, should I continue from that, or you want to understand them that
Yes, sir. Thank you, sir. So we will have the LMS KT and then you can take forwards.
okay.
Yeah. So now I would like to thank all the guests again for joining in and giving their inspiring words. So, Mr. Amar, you can actually walk us to the LMS.
Sure, Sheetal. Thank you. So, dear bright minds, once again, a very good evening and a warm welcome to the 30 hours SDP by XLR on quantum computing. So, I will just take 5 to 7 minutes of your time and we'll go through LMS portal. And on top of it, I know there are a couple of queries you have or doubts you have regarding to the attendance, certification, joining the session. So I will cover all that things in next to 5 to 7 minutes. So please listen carefully. So before entering into the KT session, can I have a confirmation from couple of you that I am audible? Just quick confirmation. Yes, those who are raising the hands, previous batch participants, great, superb. Nice, good to see. Thank you so much, guys. You can just down your hands now. Okay, so LMS stands for a learning management system, and it's one-stop solution to access all e-learning content. Not only content, but on a daily basis, how we can join the session, how we can mark the attendance, all these details will be available on the LMS portal, right? So today, to join the session, you receive one email, right? With the Zoom link and YouTube link. As today, we are going to have the day one. But from tomorrow onwards, you will be not receiving the email, but you have to join the session from the LMS portal. So in that scenario, we need to have our account activated, right? So for that reason, those who completed their registration today till 5 o'clock, your LMS access mails already triggered from our site. So you have to check your mail. While checking the mail, make sure that you are checking into the inbox. Similarly, you are checking into the spam folder as well. The first mail that you have to check, if you are a first time user of EDL program, that mail with the subject LMS portal account details by XLR. Okay. And in this mail, you will find the three important things. First thing is a portal link, that is nothing but the LMS URL. Username, that is your own email ID. And the next thing, that is a password. Okay, so with these three details, which we can easily sign in to access any of the website, any of the portal, these three things are more than enough, right? And suppose you are a second time or third time user of any of our program, or suppose if you are already registered in a previous program, so in that scenario, you will receive only one email, that is welcome to the SDP on quantum computing by XLR. Why this one email? Why we not receive the another email that is containing the password and email address and the LMS URL? Why? Because previously, whenever you registered, at that time only your account is created, right? So once account is created with the same account details, with the same credentials, you can access this course too, right? In a simple way, if I want to explain that, once we will create account on Zomato or Zepto, right? So every time if you want to order, we're not required to create an account or add any details. Directly we'll go, we'll add whatever we require and we'll order. Same way. So on the same account, this course will be visible. So those who are not registered, for them, after completing of the LMS KT, I will be sharing the link. I already shared on the YouTube. I will share on Zoom as well. Complete your registration and get your LMS access in 24 hours of time. So now with these details, I will just do a sign in or login, we can say that. After clicking on this link, what next? So just a moment, hang on. Let me reshare my screen and let me open the browser. So once I click on this link, it will take me through the browser. As per your default browser, you will land on the sign in page and there you need to provide your details. Your username, your password, and you can click on sign. Suppose, as I said that if you are registered, but you receive only welcome email and you're not remembering the password, then in that scenario, you can utilize the forget your password option. Okay. In that scenario, you can use your forgot option and you can use your mail ID, whatever you registered, and follow the same steps. Now I have my details with me. I will click on a sign in. So what next? Okay. So once I click on a sign in, I will find all these details onto the dashboard. But before entering into the dashboard part, there are a few things which I would like to explain you guys. So You can check here on top of right corner, you are able to see one option that is profile. Click on a profile, click on a settings, and you can set up your profile. But one important thing, if you clearly saw the previous PPT, then in that the password is little bit lengthy, or whatever password you received, that is also a little bit lengthy, and it's always difficult to copy paste and manage, right? So for that reason, once after your first sign in, you can update your password from your profile. Okay, that's the use of profile and setting option. Let me go back onto the dashboard. Now, the first thing, how we will join the session tomorrow. Once your account setup is done successfully, you can join the session from LMS portal from the dashboard using live session today. Okay. Here you can check SDP on quantum computing 31st August. Let me click on that. Once I click on that, here you are able to see the two options. One is join using a Zoom. Second one is join using YouTube. So, dear participants, wherever you are on a Zoom or YouTube, whatever the query or question you are going to have, keep posting into the chat box. Our team will take it up. Whatever things are happening over the Zoom, similarly, it's streaming on YouTube as well. So, no need to worry. And coming to the sharing the information about the attendance and feedback, I will quickly go to the next tab and I will explain you. One more thing, here is one option as a mark as present. So guys, doing this will not mark your present day. For that, there is a separate mechanism which I will explain you shortly. Clear on joining the session? On our dashboard itself, we'll find the live session today tab. Day-wise details will be available. You can click on the link and you can join the session. Very simple. Now, how I can access the attendance, material, session recordings, right? Or agenda, actually what I'm going to learn for this next 15 days. So scroll down a little bit and you will find your enroll courses tab. And on that tab, you can check here that SDP is available. I'm clicking on that, then you will find the curriculum. So in a curriculum, there are many sub-curriculums are available. So we'll start with the agenda. So in agenda, you will find one ebook where you will get to know that, okay, so what actually you are going to learn for this 15 days, 30 hours. Then second thing, that is attendance and feedback. So now please, again, I'm reminding you, please listen carefully. So coming to the attendance and feedback, if I click on this link, one Google form will open, but for now, this form is not active. And here you are able to see one note, the link will be active from 8:30 p.m. to 9:30 p.m. So dear participant, okay, first thing, the today's link will be active for today only, and that will be only for 1 hour, that is 8:30 to 9:30. First thing. Second thing, while submitting your attendance for all the days, make sure that you are using the single mail ID. Okay. Whatever the mail ID you are going to use on day one, use that same mail ID for all 15 days. Third thing, 60% attendance is mandatory to get the certificate of participation. Okay. Third thing, I'm repeating one more time, 60% attendance is mandatory to get the certificate of participation. 1 minute, guys. Okay, where we are? We are about, yes, certification. Then how will receive the certificate? Suppose if you are going to complete this program successfully with 60% of the attendance, then you will receive the certificate in 8 to 15 working days to your registered mail ID. Clear about the certificate? Now, I know that one cross question you are going to ask me that, sir, I just joined, I not registered, or I received the link, but I am interested for this program. How about the today's attendance, or how about the future attendance? So, dear participant, no need to worry. Our team will be sharing the Zoom link, and our team will be sharing the attendance link over the Zoom and YouTube as well. So, sharp at 8:30, you will get the link. So, it's my humble request. Don't start spamming attendance link from 8 o'clock only. Sharp at 8:30, you will get the link over the Zoom chat and YouTube live chat. Clear? Now let me go back. Once, yes, you can check it here. Below the attendance feedback, I have live session option, which I already explained, then session recording and reading material. So here itself, you will find the session recording and reading material as well, right? All things are here available. You can go ahead. Once after the class, you can go through the LMS portal. And if you are registered today, and if you're not received the LMS access, no need to worry. Your account will be activated in 24 hours. Okay, that's all. Thank you so much for listening. I'm there in the session. If anybody is having any query about their LMS certificate attendance, you can just select my name into the chat box and you can ping me. I will answer you into the chat box. Thank you so much and happy learning with XLR. So, Sheetal, over to you.
Thank you so much, Amar. So now I would like to hand over the session to our subject matter expert, Dr. Vipul sir. You can continue, sir.
Okay. So let me share the PPT. Okay. So as we have talked everything about that, today we are beginning our journey into this quantum computing. But before discussing all the things, as the convention suggests, that I want to start with a very, very basic questions. And thus, this basic question is that why do we need quantum computing? Okay. So in fact, from my expertise point of view, everybody has talked about their points in the in all the guests. But now, from my point of view, the real thing is that why do we need the quantum computing at all? Okay, so this is actually the most important question to start with. So we today we already have a very powerful, uh, we can say classical laptops or classical computers. We should turn them. Okay, so we have smartphones, supercomputers, the cloud computing, and AI systems. Okay, so naturally, someone may ask that if a classical computers are already so powerful, yes, they are very, very powerful. So based on that classical computers, we have built the overall structures of this world now, this era. That is from, we can say from the 2000 to this 2026. This 20 years has been a very, very a great landmark in this journey. Okay. So, so when all these classical computers are already so much powerful, so why do we need another type of computer? Okay, that is a very, very basic questions coming to all of you, or whether you are from faculty, computer science background, or from electrical electronics background, or whatever. Okay, or software engineering backgrounds. Okay, so this is a very basic question then when that we have developed based on the classical computers. We have developed that classical computers. We have developed that you can say the AND gate, OR gate, NOT gate operations, right? So based on that operations, we have developed these electronic devices. Okay, and from that electronic devices, we have developed the classical computers. So then now suddenly what happens? Why everybody is fasting, rushing towards this new terminology that is called a quantum computation? So this question will 100% is in the mind of everybody's. Okay. So so yeah, I was listening to 1 minute. Hmm. Hmm. So yeah, is there any chat? Yeah. So I'm seeing that a lot of people are raising the hands. So yes, there is a one point that if you want to ask something, so you can ask in your chat box. Okay. So time to time, I will have the keep the eyes on that chat box. So what are your questions? And at the specified timing of answering that question, whenever the matter will come in the teaching point, the matter will come, I will answer that question. Okay, I will take up that questions. Okay, so yes, so this is the thing that you remain active during the whole the lectures. Okay. Now, yeah, I was talking about that the question, very important question, which is coming everybody's mind, that the classical computers, why we want to replace it, right? So now the answer is not, certainly not that the classical computers have failed. No, they have not failed. We are working on this. Currently, we are working on the laptop. I'm giving the presentation to you, right? And you are attending maybe from the mobile or from the laptops, all right? So mobile and laptops, all that are form of the classical computers. You can say the this chip, right? So the classical computers, yes, in fact, very powerful and will continue to remain important. They are not going to lose their importance. Okay, first of this, just clear your view. Okay, the classical computers will not lose their importance. Even as we will move on to the this course, we will see that the classical computer will become the a very special part of this advanced quantum journey. Okay. So just remain very safe for all of you, that whatever you have studied till this year 11th or 12th classes and till this BTech first year, second year, like that. So everything is safe. Okay. So that knowledge is not going to be waste. Okay. So now the real question, that the quantum computer is also not simply a replacement of your laptop, then what is the reason we are rushing towards it? Okay. So the real question, that is something have a very deeper meaning. There are some areas where we are beginning to face the fundamental questions about the computing. Okay. So, and that, yeah, in the coming slides, I want to just explain this complete story through three connected ideas. Okay. So just concentrate on that. Today's lecture is very important. I will lay down the basic fundamental, we can say, platform for all of you for to answering this thing. Okay. If you will get it everything from this lecture, today's lecture, so the next 14-day journey will be very easy for you. Okay. You will not get frustrated that, oh, it's going upper my head or like that. Okay. So the first idea is that, yes. So the first idea is that we continuously wanted, yeah, in fact, we are using our laptops and everything, but we continuously wanted more and more computing power. More and more computing power means to say that everybody wants that in 2002 and 2004 era, when you will serve the some website, you will try to open the website, it will open on a 2 minutes or 3 minutes lap time gap. Okay. But as the this technology is going to increase and increase, the more exploration we are doing, that that time is getting in the seconds. Okay. Now, whenever you will hit the enter button, immediately the website will open to you. It will pop up. Even with the website, lot of pop-ups will also open to you. Okay. So therefore, we continuously want to first greater speed, and second thing is that computational power. Computational power means first is the speed. Second is when you are having more number of inputs. When you are having more number of inputs, then you just wanted to get it done by your laptop also. And that more number of input means, I'm not talking about, suppose you are saying 10, then you are saying 100. You are saying 10, then you are saying 1,000. No, this is considerably accepted limits. Okay. I'm talking about 10 to power 5, 10 to power 6 inputs if there was. Okay. So we want to calculate. Okay. For example, when all of us, we are going on the GMap, right? Google Map. When this Google Map is calculating the things on the one city, you can estimate how many of streets are there in the one city. Okay, there may be a thousands, or maybe there may be a greater than the thousands. Okay, so it will touch 40,000, 30,000 streets in a city. Larger cities will have more streets. Okay, and what will happen? Okay, you will say, yeah, one laptop will sufficient to calculate the all the ways simultaneously. Okay, I can accept your fact. Okay, so yes, in a one city, you can control that by one laptop. But what will happen if you will go to the state? State will have around 30, 40 cities. Then you want to compute that at the same laptop, then there will be a increased data. There will be a increase inputs. Okay. Increase means one city you are having, at least 30 cities, you may be having a lakhs of streets, right? And this situation will be more worst if you are talking about the whole country. And furthermore, you are talking about two three countries. So the everybody wants more computational power. Okay, more computational power. With this GMAP example, you can understand that what is the computational power. Okay, so power means which can do in a less time. In a normal physics way, I can say power means work done over time. So whoever is doing same work in a less, that's a computing power. Okay, so the second idea, as we make conventional electronic devices smaller and more dense integrated, we begin facing increasing physical and engineering challenges. Okay, I will come to this point in the later slides. Okay, so so third idea is that some computational problems, especially the what I was talking about, this is one of the example, GMAP system, like that other systems are also having a large number of datas. For that, the computational speed will be so much is high. So that become extraordinarily difficult for the classical computers, right? So these are the three problems. Okay. So, and one more generic thing I want to tell you, that whenever you want to compare old technology to new technology, what will be the methodology? The method will be, you just want to look up the drawbacks of the old technology. Okay. So, so the drawbacks of the old technologies, okay, is the drawbacks of the old technology, right? And and then you will see the benefits of new technology. Okay, and what your sorry, for new technology. Okay, and what your mind will think. Your mind will think that the new technology. Okay, the new technology. Okay, this new technology will dominate or eliminate all the drawbacks of the older technology. This would be your innovated idea behind adopting a new technology, right? So just like that, if we are talking about classical computer and the now new technology, that is a quantum computer, so first we have to look up for the drawbacks of the old computers. So that are the drawbacks of the old computer. Okay, so that computational power we want. So now I just coming to the more drawbacks of the older computers. Okay, so what happens actually during the 18th to 19th century? Okay, although it is related to the computer science, or you can say the computer engineering, okay, software engineering. You in the software engineering, you are all of talking about algorithm and all that things. Okay, but I will tell you that all the things are made up from hardware. Okay, your software will do nothing whenever it will not hold it by the hardware, right? So any technology which is adopting, we have to see the physical things, right? Physical things, that means physical devices. So if your old computers are evolved at this stage, a latest stage, okay, i5, i6, or i3, and like that, i5, i7, and the next generation, 12th generation, like that. So that all have evolved because of the application of the physical devices. Okay, so you cannot ignore the application of these physical devices. Okay. Uh, And I'm talking, sorry, I'm talking continuously around 10 minutes. Now I just want to all of you that if you are having some query, you can chat it. Okay. I will keep eyes on that chat and will keep trying to respond you as I will get a time. Okay. So if you have anything, any query, so how it can be replaced, how it cannot be replaced, like that, whatever the queries you are having, just you can text me or you can chat me. Okay. So yes, two chats are coming. Yeah, that is the application. Application we will come. Yeah, somebody was the question, where are the quantum computers actually being used today? Yes, I will tell you. Okay. For RF engineering, the semiconductor devices uh, and sensors. Yeah. So quantum computer will also go in depth. That is a quantum sensing. Okay. So we will be talking about the National Quantum Mission also in this. Okay. So the government of India has launched. So and this RF engineering and these quantum devices and sensor comes under the quantum sensing part. Okay. So we will be talking about more in the coming lectures. Okay. And the application I will tell you. First, just understand what are the drawbacks of the old computers and how this new technology will going to adopt and remove their drawbacks. Okay. So what is that? That will give you the clear idea then why we want to replace this technology. Okay, because everybody, this is a very basic idea. All right. So now, yeah. So what I was talking about the physical devices. Okay. So the birth of anything, any technology, the basic thing is physical devices. If you are not able to formulate the physical devices, that means diode, triodes, and everything, semiconductors, and all that, it means you are not able to realize the your algorithm benefits. You are not able to realize the your C programming benefits because all the algorithm, all the C programmings are running on the hardware, right? And if that hardware is not there, then it will be no use. Okay. So now I just want to emphasize that everybody knows about that. There is no point in talking about this, that uh, classical computer are based on two logics. Okay. Bits and bit are having two things, 0 and 1, right? So the classical computers are having this basic idea of 0 and 1. Okay. So I just want to tell you from the very beginning why this logic being adopted. Okay. So why only 0 and 1? Because uh, because whenever you are talking about anything, okay, so in the 18th, 19th century, okay, a lot of scientists, lot of people were thinking about that when we are asking to somebody and when we are having a query to somebody, okay, then query model, it has been evolved. Okay, query means whenever you are giving a query to somebody, okay, so that query will have only two answers. Okay, if I will ask you that you are attending this quantum computing program, so either you will say yes or you will say no. Okay, beside that you will have no answer, right? So if I will ask you, are you sitting? So are you sitting currently? So you will have only as two options to say. Either you will say yes, I am sitting, or you will say no, no, I am not sitting. Okay. So at each and every condition can be formulated in these two answers. Okay. So that is called the Curie model. Okay. So that, and that's why every scientist in the 18th, 19th century are believing that it is very easy. It is very easy to answer someone. Okay. Without having more troubles to the tongue. Okay, say only yes or no, right? So every situation in the daily life we can deal. Every situation means lot of situations. Most of the situations in the daily life we can deal with 0 and 1. And further, if some remaining situations are there, then that remaining situations we can deal with the combination of 0 and 1. Means yes or no. Okay. If some remaining, suppose I am talking about 70% of the situation we can deal with the queries, that is 0 and 1, yes or no. And if something 30% are remaining, that for the evaluation of that, the combination of 0 and 1 we can deal with. Okay. So that is the evaluating point of this binary system. Okay, that's called the binary system. Everybody knows about that. But why this being adopted? That is the main thing. The second thing is that this is the first thing. Okay, the second thing is that now, if I will talk about the daily life situations, so you will be maybe possible. So many of you will be knowing these examples or not. Uh, I can take suppose I'm teaching you, okay, and I'm taking this quantum computing course, and all of you means students, okay. So we can say the teacher and students. Okay, so these are the when we are talking about this system. So this system is having two inputs, teacher and students. Okay, let me do something from here. So maybe possible some of you will feel uh, uh, boreness because of you may think about that. This is a very basic thing what the sir is telling to us. Okay. Yeah, this is very basic, but we have to start with the basics, right? This is the first lecture. We have to start with the basic, right? So suppose a teacher is there and a student is there. And if I will talk about the output of this system, the output is called study, right? Study. Okay. Now you will say teacher can have only two inputs. Either it can be present or not, right? So it can be present means one, it cannot present means zero. The students, it will also have the two inputs with the each condition of teacher. Suppose if the teacher is present, it can have now two conditions with the student. Teacher is present, student is not present. Teacher is present, student is present. Okay. Now, with this condition of teacher, also there are two conditions that teacher is not present, but the student is also not present. Teacher is not present, but the student is present. Okay. Now you will, I think the clever students will understand now what I'm talking about. Okay. I'm talking about some gate, right? That is the classical gates. Okay. So that means when this one and zero condition is there, the study, you can think about the study. Teacher is present, okay? Teacher is present and the student is not present. The study will be zero. Teacher is present, student is present, study will be one. Okay. Uh, 0 0 student study will be zero. No study will be there. Okay. Teacher not present, student present. Even then study will not be there. Okay. So, okay, see there. So, let me take another pen. See there, there is only one condition that both are 1 1, only then the study will be 1 1. Okay. So, what it means? It means the daily life situations are comprising of the AND gate. Okay. So this is only one example. You can set it. See, you can set it to the example of the OR gate also. Okay. So the anybody can set it. What will be the example of the OR gate? So suppose let's see the chat. One minute. Oh yeah, the bits and qubits. What is the difference? Yeah, all these questions will be answered. Yes. Yeah. And gate, yes, and gate, yeah. There's somebody else answers. Yes, right. So, yeah. Now, the example of the OR gate, uh, only see, the intention is not to show that you are not getting, you have not studied all these things like that. The intention is just understand the intention of my giving all these examples. So, this example, I'm only telling you that in this example, you can estimate that every situations can be deal with the combination of 0 and 1s. Okay. So just like I'm talking about teacher and student system, okay, if I will talk about suppose if I will talk about suppose there is uh, there is a one person and there is a suppose ball, okay, and suppose there is a bat, cricket bat, okay. And suppose this person, I will say that this person is saying that bring the ball or the bat. Okay. What this person is saying, this person is saying that I want ball or the bat. Okay. Or means or, right? I want ball or bat. So when he is saying his wishes that he wants ball or bat, then it means what it means? It means if you will give him a ball, that means his wishes will complete. Wish will complete. So if you will take the output, the wish, if you take wish as a output and ball and bat as a input, this is ball, this is bat as a input and wish as a output. Okay. Then ball, now you can take, say, ball. If ball is not there, bat is there, then wish is completed. Okay. Because he is saying that either I want ball or either want ball or I want bat. Okay. So now if he will say ball, you are giving only ball, you are not giving bat, which is completed. Right? And if you are giving 0, 1, 1, 0, okay. If you are giving ball, no, bat is also no, which is not completed. Okay. So we can say the wish is not completed like that. Okay. Now there is one more option. Yes, you are giving ball also, you are giving bat also. So wish is also completed now. Okay. So yeah, now everybody will say that yes, this is example of OR gate, right? So I think with these examples, you can estimate that the intention is to show you that every situations can be deal up with the AND gate, OR gate, combinations of AND and OR gates like that. Okay. And when we are talking about the combinations of this AND gate, OR gates and NOT gates, okay, one gate is also remaining. That is NOT gate. Okay. So inverter in your homes, the inverter is a very example, very good example of the NOT gate. When you are talking about the light as an input and talking about the home light as an output, okay. So you can say when your light is gone, the inverter is on, right? When your light is present, your inverter is off, your battery is off. Okay, so that is example of a NOT gate. So means see, all these examples, I want to show you that these classical gates are used to estimate the daily life. Okay, the examples, they are simulate the things of daily life. And furthermore, typical situations, when furthermore typical situations are there, then what you have to do? You are being to you are being to program that one through these logics, AND gates, OR gates, NOT gates. And when you are instructed to program that one, sequencing, keeping the sequences of AND gate or OR gates like that, that sequences is called the algorithm. Okay. So in very basic form, it is called the algorithm. Some students will think about, oh, what are you talking about? This, no, this is not the algorithm. Yes, but yes, basically that is called the algorithm. Okay. So what sequence you want to adopt it, what order, okay, and what task in a sequencing order, that is called the algorithm. Sequence depends on your programmer. Okay. So with these things, you are able to evolve the classical computers through the series of AND gates or gates like that. Okay. Now, the basic problem. Now coming to the very basic problem. Okay. I want to remove this. Okay. Yeah. So now this all these things are called logical steps, and there is no ambiguity in the logics. Okay, everything is called you can say the classical era. Okay, and at that time you may or may not be heard that this is called a Turing concept, a Turing machine, right? So what is the functional thing is that at that time it is believed that yes, every logic has come from the science, right? Okay, so that time it is believed that the universe is deterministic, okay, and it is continuous, and also it is predictable. Okay, so deterministic, continuous, and predictable. I can give you one example of that. Suppose you have studied Newton's laws. Okay, so all the three laws of Newton's motion, right? That is V is equal to U plus AT, like that. All the three laws, as is equal to UT plus half AT square. Okay, okay. Some of the questions I have not answered here because I will be answering in some lectures where I will get. Okay, but these questions, do not worry about that. I will answer all these questions. I will gather all these questions. Okay, so whenever whatever questions you have chatted me, you have given on the chat, yeah, I will keep the record on that, and the time to time I will answer. Okay, no problem. Okay, no question will be left unanswered. No problem. Okay, you just flood your questions in the chat. No problem. Right. So, yes, V is equal to U plus IT, like that, and something V square is equal to U square plus 2AS. Okay. So, deterministic means to say, if you are knowing the initial condition, everybody knows about the application of these equations. Okay. If you are knowing the initial condition, initial velocity or initial condition, okay, where the point is 2 meter, 3 meter, where the distance is, okay. If you are knowing the initial velocity, okay, that is u, okay, then after a certain time, means t time, after a certain time, hmm, after a certain time means t time, you will get the velocity that is called the final velocity, right? This is the classical physics is telling you, means Newton's laws and everything. Okay, so that if the t may be 1 second, t may be 10 second, t may be 60 seconds, okay, or 60 minutes, okay, or t may be 24 hours. That is called one day. Okay, the unit is change only, but nothing else. Okay, when you will put the value of t is equal to 24 into 60 into 60, like that, you will get the final velocity after one day. And when you will get the final velocity at one day, then certainly you can have the final velocity at the 30th day. And surely you will have the final velocity as 365 days. That is called 1 year, right? And yes, definitely, when you will put the value of t 365 into, suppose 20 years, you want to talk about 20 years, then 20 into 365 into 60 into 624 into 60 into 60. When you will put this amount of value, certainly you will get the value velocity, final velocity after 20 years. Got it? So that is called the deterministic nature. Okay. So the classical ones, the classical physics allows us to determine the conditions at the futuristic level. Okay. So that is the story. So we can predict the future according to the classical physics. Okay. If we are, yeah, 100%, there are restrictions. If we are knowing the acceleration, okay, we can predict the future. Okay, even we can predict that where after certain time where the object will be there. Okay, after 5 minutes, for 5 meter or 10 meter or 10 kilometer, like that. So everything we can predict. That is called the prediction. That is called the deterministic nature of the universe. Okay. So, in 18th century, the science has evolved in such a way that whole the universe was very, very deterministic. And the deterministic, from this deterministic nature, from this deterministic nature, the logic has come. Logic has evolved. Deterministic means either there will be yes or no. So from this nature, logic has evolved. Okay, deterministic means we can determine either it will be there, yeah, or not. After 20 years, it will be there or not. After 50 years, it will be there or not. So we can, it means, so when this classical physics suggesting that future is very, very predictable and deterministic, and this deterministic nature is suggesting us that giving the logics of yes or no. Okay. So that is the classical physics feature. Okay, feature of the classical physics or main symptoms of the classical physics. Okay, got it. Now coming to the uh, 1 minute. Yes. Now, that was, I was talking about 18th to 19th century. Okay. So if you will, I hope that all of you have gone through the 11th and 12th physics. Okay. No need to rewind that physics. Okay. Uh, but only I will touch some points. Okay. So that you can get the connections. Okay. So my aim is to connect everything from the surface. Okay. I'm just giving the connections, connecting wire of every principle of physics. Okay. And only you have to connect then in series. Okay. So that's why I'm talking about. Okay. So what happens? So previously I was talking about 18th to 19th century. Okay. So 18th, 19th century means 1800 to 1900 I am talking about. Okay. So 18, 1900, the universe was deterministic and governed by the classical physics. Okay. But around 1890, last decades of this century, 1890 to 1900, okay, you can only just align these things. Okay. Yeah. So in this decade, the some problems of classical physics has been arrived. Okay. Why the problem will arrive? This is the basic principle that if we are talking about suppose there are 20 phenomena of physics in before the 1900, suppose. Okay, if I am wrong, then you can consider 50 phenomena. Suppose there are 50 phenomena, and that phenomena scientists were evolving before the 1900, and suddenly if new phenomena will arrive, okay, new physical phenomena of nature will arrive, then certainly scientists will evolve that phenomena and will try to explain that phenomena with the older physics. That is called classical physics. Okay. The same thing happens at this decade, in the last decade of this 1890 to 1900. What happens? There are some things, some phenomena arrived, and scientists were unable to explain that phenomena from that classical or deterministic nature of the physics. Okay. So where before the 1900, the Newton's laws was fitting everything. Okay. The Newton's was said the scientist of the centuries and centuries, not a 1 century, centuries. Okay. So, wow, yeah, Newton's has given a lot of laws. Newton's has given the classical differentiation equations. Newton has given calculus. Newton has given gravities. Newton has given these Newton's law. Yeah. Okay. So everything has given by the Newton. So, but all these are certainly when these phenomena, black body radiation, okay, photoelectric effect. I think everybody knows about that, black body radiation. Everybody has studied in 11th and 12th physics, okay. Photoelectric effect, the atomic spectra, okay. So this will be something new to you, okay. Maybe or may not be, okay. The spectra means Lyman, Balmer, Paschen, Beckett fund, right? Okay. So now I think most of your students are reminding that thing. Yeah, I have studied. Okay. That are called the spectras. N is equal to 1 to 5, 1 to 3, 1 to 3, like that too. Okay. So these structures, black body radiation phenomena, photoelectric effect phenomena, atomic spectral phenomena. Okay. And also there is a Young's double slit experiment. Oh, I forgot to write it. Young's double slit experiment. Okay. At some point, now you are thinking that we have enrolled on the quantum computation course. Now, what this is telling us that physics, pure physics. Yes. If you want to understand the quantum computation, then 100, not 100, 200%, you have to go in the roots of the physics. Okay. Because this quantum computation arrived from that. Okay. And why I want to emphasize more and more on this root of physics, because when we will continue to come on the quantum computation, then you have to change your mindset, because we will be dealing with the new thinking of the physics. Okay, that is called the modern physics. Okay, or quantum physics. And the quantum physics is completely very strange. Okay, I'm coming to that point also. The quantum physics is completely very strange. Okay, so your mind will not accept and you will not digest that things. Okay, until unless you will be knowing the drawbacks of the classical physics. You will be knowing that where our classical physics, where we have studied from the very, you can say childhood to now, we have studied all these things, Newton's laws and everything. And you will not digest that all that laws will fail suddenly. Okay. What will happen to the world? Nothing has changed in the world. But you will say, when nothing has changed, then why, why all these laws are failed now? So you have to go, you just take a patience. Okay, don't think that today we are not studying quantum computation at all. Okay, we are studying the roots of the quantum computation. Okay, so roots is the quantum computation fundamental is quantum physics, and the root of the quantum physics is I am detecting here. Okay, the quantum physics has arrived because the classical physics has failed. So what is the classical physics? I told you in the earlier two slides. Okay, now what is this? This is the transition thing. Okay, that before 1900. Okay, that was the classical physics era. Okay, everything has discovered. Either there is a kettle, steam power kettle, okay, in the steel that is going with the very force, okay, and that have James Watt has arrived that yes, there is a power in the steel. Everything has arrived in the 1700 something, 1800 something, 1900 like that. Okay, so all that summarizes, you can say, the classical physics. Okay, so but that classical physics are failed to some extent or to the larger extent when we are trying to explain the black body radiation. Okay, when we are trying to explain the photoelectric effect, when we are trying to explain the atomic spectra. Okay, and mostly when we are trying to explain the Young's double slit experiment. Okay, everybody is knowing about this 11th and 12th physics. Okay, to explain everything, all these things, okay, the classical physics was not able to compete. Okay, so to explain everything, okay, that is related to the nature of the light. Okay, so actually the scientists were evolving the nature of the light. Okay, so what the light is a wave or light is a particle. That is the main quest for the scientist. Okay, quest means search. So means search for the scientist. Okay. So let me see till this point. Is any queries coming? No. Okay, fine. So I will remind you that keep interacting with me. Okay, keep flooding your questions. Okay, no problem. Okay, you will be saying that maybe possible you may be thinking that you are discussing about physics. We know the physics. No problem. We are coming here for the quantum computation. So from the if you are talking about that point, then from next day onwards, you can have the quantum computation questions. Okay. So yes, but I have to tell you that physics. Okay. So sorry that I'm teaching you physics, but yes, it is a very important point. Okay. So the nature starts misbehaving at this decade. Okay, at this decades, there are some three phenomena I told you. In fact, there are six phenomena which I have not included because that is the more complicated ones. Okay, so that is not touch the 12th physics. So I have only included that phenomena which you can say yet we have studied these things up to the class 12th. Okay, so yes. So, in the last decades, these three phenomena were not able to explain by the classical physics, and in the 1900th century, the Planck came with the idea that light consists of bundle of photons. Everybody knows about this, okay? And whose energy is given by h nu. Okay, everybody knows about that. Okay, so the quest was I was talking about the light nature of the light. Okay, the nature of light. Okay, actually this was the quest. This was discovery in the nature of light. Newton said. Newton said in the you need not to remember, but yeah, I'm telling you. Newton said in 1519. That is 1519, Newton said light consists of corpuscles. Okay. Okay. I'm not going in detail. I'm only touching the points. Okay. Then in 1630, Huygens said, everybody knows about the Huygens wave theory. Okay. Huygens said light consists of a wave. Okay. And then, but at that time, Newton was considered the scientist, greatest scientist. So Huygens was neglected. Okay, so Huygens was neglected that time. Okay, even Huygens has given the wave theory, but that was neglected. Then 1820, uh, Young's double slit. Okay, Young's double slit came. Okay, and Young's double slit proved that light is a wave. He has given the stamp, or you can say evidence. Okay, or you can say he has stamped that light is a wave. Okay, so when he has stamped light is a wave, then okay, then all the scientists had believed that yes, now light is a wave, and you are also continuously evolved with this methodology that light is a wave. Okay, everybody knows about that. Your subconscious mind will tell us that yes, light is a wave. Okay, so yeah, when suddenly when somebody will attack you this question, what is light? You can say light is a wave. Yes, of course, light is a wave till this point, 1820. Okay. Then if I will go later at 1860, 50 around, okay, at 1850, Maxwell said that light is a not only a wave, it is an electromagnetic wave. And he has also proved it is a transverse nature. It is a transverse nature. Okay. Yes, it is a transverse nature. Now, any electronics background person can relate this. Okay. Uh, so there are two stems. So that is the stem two. That light is a wave. Stem two. So there are two stems are there on the wave. Okay. On the wave. Two evidences are there on the wave. Okay. Scientists have proved. So that is considered as a wave. Okay. But when this 1890 to 1900, this wave nature was not explaining these three or four phenomena, in fact, six phenomena, which I have not included theories. Okay. So not explaining that phenomena, then in 1900, Planck said that light is a bundle of photon. Light is a bundle of photon. Okay. So when light is a bundle of photon means you can just concentrate on staying on this word photon and bundle. Bundle is something which is one entity. So there are a lot of entities, then you can form the bundle. So that means bundle of photon means photon is a type of particle. And that bundles we are talking about, that means we are talking about bundle of particles. Okay. So that means you can say that at this era, at 1900, Planck again said, who? Planck again said it is a particle. Photon means particle. Okay. So the overall summary is first it is said a particle, then it is said a wave and proved, and then again 1900 it has turned to the particle. Okay. So the whole scientific community now dividing into the debate portion. Okay. Okay, my God, somebody is saying the particle, somebody is saying the wave. And again, somebody is saying, no, no, it's not a wave, it's a particle. So what is all these things, ambiguities? Okay. So most of the students can relate. Okay. And they can answer this ambiguity. Okay. So this ambiguity is solved by de Broglie. Okay. So this ambiguity is solved by de Broglie when I will talk about more ahead. So de Broglie has came in 1924. Okay. So till 24 years, this debate has been continued, and in 1924, de Broglie has ended this debate. Okay, why I am telling you this is the basic foundation of the quantum, even quantum computation. Okay, so de Broglie has ended this debate by saying that it is a wave also, and it is a particle also. And this is a very, very strange thing. No, nobody can accept this thing. Okay. That's why I'm talking about. Most of the students will not accept. It is a wave also and it is a particle also. Before the de Broglie, everybody is saying that either there is a wave or there is a particle. Okay. Before the 1900, everybody is saying that either there is a wave or there is a particle. Means there has to be one condition. Okay. So either or means you can say anybody, you can assign a 0 and 1. Either 0 or 1. Okay. But de Broglie have said that yes, it is a wave as well as particle. Light has a wave as well as particle, and this he has proved. Okay, so Davidson and I think all of you have studied all these things in the modern physics in 12th. Davisson and German experiment was there, and they has proved that yes, it is. So wave and as well as particle. It is not or. Okay. So the wave as well as the particle, and that is very typical to digest. Whenever there is a point to come in, you have to write in the paper. I think you have studied and you have learned everything like a to tota like that things. So wave and particle. Okay. But this wave as well as particle, that has laid the foundation of the quantum computation. Okay. So wave as well as the particle, that means what it means. Before that, it was considered either there is a wave or there is a particle nature. Okay. Some phenomena are proved to be a wave nature, some phenomena are proved to be particle nature. But the de Broglie is saying it is a wave as well as the particle. Okay. He has given one restriction that I will tell you later. Okay. But he has said that the wave as well as particle. Okay. So that means both the nature it will have. Okay. So that means if any entity will have both the nature, means light will have both the natures. Okay. Both the natures means not only 0 and 1. Now you can say, before that it was saying that either 0 or 1. Okay. But now what de Broglie said, if you will see the computational point of view, you will say the de Broglie said there is a characteristics of 0 and there is a characteristics of 1 also in something. Okay. There is a characteristics of 0 and there is a characteristics of 1 in something. Okay. And now whenever you will think about this, there is a possibility of 0 and there is some possibility of 1 also. Okay. Or if suppose if you not you do not want to think about computationally, not 0 and 1, you can think about like particles like that. Okay. Let me delete something to write it here. Hmm. So, yes. So just keep chatting me. Okay. Keep giving the questions to me so that I can answer you. Yes. So, uh, so whenever de Broglie is saying it is a wave as well as the particle. Okay, you can say wave as well as the particles. So now it will have a lot of possibilities. So lot of possibilities means maybe possible it will have a 30% of wave nature and 70% of particle nature. Okay, this is one possibility. Second possibility, maybe possible it will have a 40% of wave nature and it will have a 60% of particle nature. There is a possibility. Okay, so like that, maybe possible 32% of wave nature. Okay, and 70, no, 68% of particle nature. There is another possibility. So means intention to say that if you want to see that this thing in this point of view, that there are not the one possibility. This is not a one sentence that wave and particle. Okay, that's it. Okay, we are agreed. No, this is not like that. So whenever we are talking about wave and particle, okay, when we are talking about Ram and Shyam, when we are talking about something, okay, so and somebody will having a, both the character Ram and Shyam, then always you have to think about how much percentage of Ram it will have, how much percentage of Shyam it will have, characteristics of Shyam it will have. So when you will talking about the percentage of probabilities, then this percentage is called a probability. In fact, in the when we're talking about the physics, then when you are talking about the possibilities, then that means there are different form of that person which is having a both Ram and Shyam characteristics. So that person maybe at this stage 30% Ram, 70% Sham, maybe at this stage 40% Ram, 60% Sham, maybe at this stage, and there may be a completely infinite range of these figures. What I'm telling you, okay, you can set up 20%, 80%, you can set up 21%, 79% like that. Okay, so there will be infinite range of things. So from that, what I want to prove it, I want to prove that because of this physical ambiguities that it will have both the wave and particle, even only this sentence has resolved one sentence into the many sentences. Okay. Now there will be a lot of confusions. Okay. So, and same thing will happen when we will study the qubit. Okay. So somebody was asking that what is the difference between bit and qubit? So that is a difference. So now these conditions, all these conditions we will tackle about, all these conditions has tackled by the quantum physics. Okay. So you from the classical physics, you cannot handle this condition, 30% wave and 70% particle. You cannot handle this. Okay. So this is just like analogous to this one. Okay, let me once delete the thing. So this is just analogous to this condition that you will say that if I'm asking about if this person, at the point A. Okay. So when I'm asking about this person is at point A, okay. So classically you can say this person at point A maybe yes or no. Okay. But now when you will think about this possibility, so you will say maybe possible, it will have both the possibilities, yes and no. So it will have 70% yes and 30% no. It will have 60% yes and 40% no, both the characteristics when you will talk about this example. Okay. So how it can be possible? So this is equivalent to say that if I am saying that you are at the Bangalore, okay, you are at the Bangalore or you are at some other place, suppose Jaipur, okay, then and then it is not 100% correct. So quantum mechanics is saying that yes, after the de Broglie, it can you can say that yes, we are at suppose 90% and 90% at Jaipur and 10% don't know. Okay, that is yes, 10% don't know. You can say okay, so that you can resolve that one sentence into the many conditions. Okay. Now, if I will talk about quantum mechanically, now I want to answer this bit and qubit. Okay. So I will answer you all the questions, but at the appropriate places. Okay. So now if I want to answer that, what is qubit and qubit? So bit and qubit is that bit, we are saying it is having a 0 and having a 1. 0 means 0%. 1 means 100%. Okay. Now, when you are talking about qubit, Q stands for quantum and nothing else. Okay. QU, that is stands for quantum. Okay. Quantum, nothing else. Okay. So it has bit. So because when you are talking about quantum, yes, 0% it will have. Okay. That is a 0. 1%, sorry, 100% it will have. That is called 1. Along with this, it will have both the characteristics. That is 30%, 30% 0, 70% 1. It will have another characteristics, maybe 40% 0, 60% 1. Okay. So like that, there may be lot of infinite states are there. Okay. Infinite things are there. So that is called a qubit. Okay. So bit that is comprises only and 0 and 1 condition, but qubit will comprises a lot of conditions. And these conditions, as you can say, this condition is called intermediate conditions are called superposition conditions. Okay, the superposition is states. If you want to call it in the terms of a state, that is called superposition states. Why superposition? Because it is superposing the two things, 0 and 1. Okay, 0 and 1. Okay, superposition two things, 0 and 1. Okay, so all these conditions are called superposition states. Okay, because all 0 and 1 states are superimposing on each other. Okay, yes, in fact this superposition world is also comes from the Young's double slit experiment. Okay, where we are talking about the superposition principle of the waves. Okay, so we will talk about in the next class. Okay, yeah, so that is the difference between bit and qubit. Okay, so I think I will be succeed to explain you the roots and basics of this how these bits and qubits have arrived. Okay. So now let me finish for the 2 minutes of this 2 or 5 minutes for this the roots of the physics. Okay. So yes, now when we are talking about, so let me delete this history, timeline history, only to remind you. Okay. So yes, now when according to the physics, when de Broglie has said that, okay, let me remove this thing also. When de Broglie has said that, yes, it is a wave as well as the particle. Okay, but de Broglie has given one restriction also, that whenever somebody will see, it is just like in Hindi it is called a Bhairupia, or you can call it another term for that in your regional languages. So it is just like a Bhairupia, right? So whenever somebody will observe this one, so it may have either a wave or a particle. Then this condition will convert into this condition on observation. On, you can say, observation. Okay. So mean to say, before the observation, when the light is not being observed by somebody, okay, it will remain in the coexisting nature of wave and particle. Nobody can say how much percentage of wave, how much percentage of particle. Okay, according to the physics. Okay, but whenever somebody will observe, okay, then it will change either to the wave or to the particle. Okay, then it will fix their position. It will give you a definite answer, that is 0 and 1. Okay, so just like that in the quantum also, quantum computation also, when you are talking about qubit, these superposition states will remain in floating states. Floating means to say it will go either 70%, 30%, 60, 40, like that. Okay, so nobody can understand these things. Okay, it will remain in the floating state. Once it is being observed by somebody, okay, when this is being observed by somebody, it will fix up to the position of either 0 and 1. Okay, so the superposition states will remain in the ambiguity states. Okay, I should do with some other color. Like yes. So the superposition intermediate states will remain in the ambiguity. Okay. But if somebody will observe them, or somebody observe means if somebody will try to measure that states, then it will immediately convert to the either 0 or to the 1. Okay. Either 0 or to the 1. So there is a condition. Okay. De Broglie itself has given this condition. Okay. So that whenever somebody will try to measure these things, okay, and these conditions has summarized in the uncertainty principle of physics. Okay. Uncertainty principle of the physics. Okay. You cannot measure simultaneously the position and the momentum of the particle. Okay. Or you can say wave. Okay. So that is coming from that. Okay. So yes, so de Broglie not de Broglie only said this thing about light. He has said this thing about electron also. The electron can have both the nature, wave as well as particle. Because when he was talking about light, light is having a wave nature. Then he's saying no, it has wave as well as the particle nature. But when he is talking about the electron having a particle nature, so he's saying if I am saying that both the things are interchangeable, then particle nature will also have the wave nature. Okay, so when he has arrived at this electron point, and Davis German also proved that, then he said to anything in the world. And then he said to anything in the world. So anything in the world, anything means everything is comprised of the atoms, molecules, and electrons. So anything in the world can have these two natures, wave and particle. Okay, and when it is having these two natures, so before the measurement, before the observation, these two natures we can split up into the intermediate superposition states, 70-30, like that, okay, in airy things, okay. But whenever it is being observed, it will immediately convert to the either 0 or 1. There's a definite position, not a floating ones, okay, not an uncertainty. The uncertainty will convert to the certainty on being observed. And that is a very, very basic principle of the quantum computation. In the algorithm, we will be talking about these things. Okay. So all the algorithm are comprised of this statement that on measurement, it will give you 0 or 1 definite state. Okay, when we will try to build up the quantum circuits. So, and when we will try to measure this, so this statement will be very useful for that. Okay. So with these things, just I want to end this lecture. Okay. So I think tomorrow we will meet it and we'll continue these things in the next journey. Okay. So thanks to all of you. If there is any question, you can put it on the chat. And one minute, let me remove everything. Okay. So yes. I'm from commerce background. I have no knowledge of computing. Will this? Yes. No problem. I'm teaching in such a way. I'm touching everything. Okay. So and that's why I'm saying if you are from different background, you have the right to ask me. No problem. The questions. Okay. I will answer all these things. Okay. So here's anything else. The light is what, wave or electrical wave? So light is wave and practical. 50-50 are also, yes, 50-50 also, 70-30 is also the possibility. Yeah, and your first question, whatever, I'm not naming that. Yes, what the first question, that light is what, wave or electrical wave? No, it's an electromagnetic wave. Okay, it's not the electrical only, it is the electromagnetic wave. Okay, so magnetism is also there. That is the EM wave, electromagnetic. Okay, in maybe if you have some scientific background, maybe you have studied the electromagnetic spectrum. Okay, so visible light, infrared light, ultraviolet lights, all these things, radio waves, all these things. Okay, so yeah, it's a electric. Uh, any more question? Mm, Okay. So how to mark our? You can ask to the administrator. Okay. So, okay, just handing over to the Amar or Nitya or something, Shidal, whoever is there.
Yes, sir. Amar is yes. Yeah, thank
Okay,
you, sir.
okay.
So, dear participants, we're done with the day one of session. I already shared the attendance complete backlink into the chat box. From 8:30, I shared it a couple of times. I'm resharing that. If anybody's missed, please mark your attendance and share your valuable feedback about today. And we'll see you on day 2 sharp at 7 o'clock tomorrow. Okay. So till the time, take care of yourself, take care of your family, and bye bye. And happy learning with Excel. Thank you, sir, and bye.